Good morning to all. Respected Principal Sir, Dr. C.V. Narasimhulu Garu, Guest of Honor, Dr. J.Ravi Kumar Sir, and faculty members and participants. Very good morning to all. Myself, Narsaya Domala, Assistant Professor, Department of EC. Welcome to all the last day of AICTE sponsored 2 weeks ATAL FDP on recent trends in signal and image processing with hands-on training using MATLAB. This is my privilege to introduce the today's speaker of session, Dr. J.Ravi Kumar, Professor, Department of EC, NIT Warangal. He is completed BE from the Usman University, as well as Master's from the JNTU Kakinada. He is completed from the PhD NIT Warangal. He has the world's 77 publications, the various international journals and as well as the conferences. Also, he has 5 research projects funds by various bodies such as MHRD, SERB, the DSD, Government of India, ICCS. He guided for 5 PhD students as well as and currently guiding for 5 students of PhD students. He is also he is an associate editor of International Journal of VLSI Design Tools and Technology, associate editor of MECS International Journal of Image Graphics and Signal Processing, Hong Kong. He is a member of UGDAC, Department of EC, NIT Warangal member. He is visited the Cambridge University and Oxford University, United Kingdom in 2009. Now, I request to Dr. J. Ravi Kumar sir to take on session on convolution neural networks for and digital recognition. Thank you, sir.
Participants, you are all fortunate to have today Dr. Ravi Kumar with us. Earlier, when I conducted one FDP sponsored by AICTE in Geetanjali College of Engineering Technology, sir also gave 3 hours talk. Mostly that day also in last session. Okay. Today also he is with us to deliver a talk in the last session, and after that we can have some 15 minutes evaluatory session. Okay, sir also will be presenting. So I request you all of you to patiently listen, and if you have any doubts you can clarify. Okay, so with these few words I request Ravi Kumar sir to conduct the session.
So the topic given is convolutional neural network for hand digit recognition, right? So first of all, we should know what is neural network, and then why we are going for convolution neural network. Fate of ECE is very bad now. How? All students are taking admission in which branch? Huh? So now if you want to migrate to AIML, then what you should do? You have to learn, na? There is no alternate, right? Correct? So you have to update yourself. And these things are not that much difficult. On fingertips you can do. So possible, if internet is there, I can show you with Google Colab the code execution of the neural network for hand digit recognition, right? So I challenge how much time you have, 2 hours, 3 hours, 4 hours. Be with me, I'll teach you. So first of all, you should fix your mindset. Keep this 2 hours of discussion or 3 hours of discussion or 4 hours of discussion. I should learn something. Correct, na? Then, if I learn, then which way I am going to get benefit out of this? Correct, no? This you should know. Any moment if you feel bored, stop me. There are so many stories to be discussed. Correct, na? Huh? Right, chale. So, what we are going to discuss today is, objective is clear, na? So, you have to do examples of this convolution neural network. Now, this buzzword you are listening these days, right? CNN, convolution neural networks. Tell me few applications which you come across CNN. Tumor detection. Sir, you came for FDP guest lecture. We came for certificate. Mutual understanding. Don't ask any question. And asking questions are not permitted. Do your task and go. Is it? No, na? Should not be the case, right? See, class is absolutely silent. I know how difficult it is to teach in Farah and Vasavi and NIT. NIT, our task is very easy. If teacher is competent enough, student will listen. Student will not disturb teacher. And teacher is telling something, attendance if it is mandatory, he will sit in the end, in the back bench, he does his own work. Teaching in Farah, Vasavi, Lords is very difficult. Oh God. So how to get their attraction is a very challenging task. You are teaching a class. Class is absolutely silent. Nobody is talking. Do you feel happy? Mera class to ho gaya. If there is an interaction, then you feel like, I delivered today. The moment you deliver a good lecture, how satisfied you are. Yes or no? So anyhow, so you are going to be with me for 2 hours initially. Based on that, we may extend. Your principal permits. All right. In the end, I'll show you the research papers. Generally, Chinese names will be there. Why not some Indians name these many colleges? So this is the second objective of this kind of FDPs. One is teacher has to learn and quality of the education has to be improved. And research content of the India has to be improved. Research gives quality education. Why I need to do research? Research gives quality education. The concepts are verified. The verified concepts which you go to a class, the delivery is different. Okay? Chalo? Right. Generally, I will be asking questions. If you have any objections, you tell me. In my online class also, I used to call by name. Is there in Srinagar or somewhere? Okay? All right. So now let us go ahead. Digit recognition, hand digit recognition. So one application of CNN is what this digit recognition, hand digit recognition. So many ways you write letters, na? If it is 7, then somebody will write 7 like this, 7 like this, 7 like this. In any case, it has to identify 7. Sir, where do we use? OMR sheet. That OMR sheet, if you try to do, then if digit recognition is pakka, bubbling is not needed. Yes or no? One more application of CNN is this cancer detection, breast cancer classification, whether you have, based on the tumor size, whether you have tumor or not, is what you can say. Right? And there are n number of applications. In VLSI, you can apply. Just go home, Google. CNN, VLSI, CNN, signal processing, CNN, embedded system, CNN, communication, CNN, antenna, CNN, patch antenna. Whatever you are, it is there in all the fields. So what is so speciality of this? And how do you use this for image processing is what we try to see this particularly in this particular class. Now coming to the images. So now this is what one particular image. So this is a image and this we call it as MNIST data set. This image data set which we get hand digit recognition, the image is 7. So when your neural network reads this, then it has to say like it is 7. Yes or no? That is a task. Right. So what is so difficult? Why can't we do it now? Now we are all easy. CSC. Triple A. Engineers, na? Correct, na? Yeah. So now, given task is this. This digit need to be recognized. Engineering point of view, like it is a task or project given to you. Your principal or your chairman sir says, student when he is coming, he will hold on a paper his identity by writing, identify and then get his name and then his class. So you need to design a product. How do you do? Task is this. How do you do? Electronics engineers, computer science mostly you do image processing, right? First thing to read that object, what do you need? Camera. Camera is what you need. This camera, where do you connect? Computer or what? Computer means 40,000-50,000. One computer you put it at security guard means will your chairman principal will allow? No. So which device you have to put there? Mobile 6,000, 7,000 mobiles. Okay. But mobile, okay. But a standalone device need to be put over there. So the first device which comes in mind is Arduino board. Mobile costs 6,000. Engineer always thinks everything in economical way. So you said mobile. Mobile is also 6,000, 7,000. I want the design to be much lower cost. Then Arduino. So Arduino, can you connect camera? Arduino is available for 300 rupees. Now 800 after COVID. Right. So can you connect camera? No. The next device is what? Raspberry Pi. So you have to use Raspberry Pi. So camera has to be connected and to the Raspberry Pi. So in Raspberry Pi, which controller is there? Which processor? ARM. Right. So you write some program in it. What is so big problem there? Camera is giving you the digits. Video is recorded. You convert that into frames. The frame look like this. Correct, no? So what is the problem? First of all, we have to understand what is image, right? So this MNIST data set, the image is of size 28 cross 28. Right, 28 cross. If you just Google, for getting this data sheet, you have to go to Kaggle website. Right, Kaggle website. Download these data sets. Okay. Right. Now, this image is of 28 cross 28. Image can be considered as a matrix or a two-dimensional signal which is arranged in pixel rows and columns. Each pixel has an intensity value, correct? So the image, I didn't give a color image, I gave a grayscale image. So pixel intensity values varies from 0 to 255. Correct, no? So this is 28 cross 28 means what? 28 rows are there, 28 columns are there. Each pixel intensity value information is there. Correct, no? Correct. Now this is there. So with MATLAB, if you want to read, IMRead is a function you use, but your principal is not allowing you to install computer there. MATLAB you cannot bring. Can you run MATLAB on your 4000 Raspberry Pi? No. Right. So then OpenCV, libraries. So you have to use this reading function. Matrix information is what available, na? Right. So this information need to be, like water bottle is right. So this information need to be understood and processed, na? So, but we as a human, we are doing, right? How we are doing? Yeah. You tell me how this digit 7 you said. Already you learned. Means what? No, no, no. Correct. So this, from where, which part of the body this comes in? Brain. In brain, which part is responsible for this? Your brain neural networks are responsible for this. Your neural networks got trained. Your neural networks got trained. When you are in childhood, your mother or father, who's the beginner teacher, would have said, beta, when there is an unknown quantity, you have to count. So when there is an unknown quantity, count like 1, 2, 3, 4, 5. Beta, 1, 2, 3, 4, 5. So each one is called iteration, and after that you go for testing. This is called training phase. Another one is called testing phase. Correct, na? So now neurons has to be trained, has to be tested. So your neurons are getting updated. Correct, no? So then when you are asking this, beta, how many these are? Then child may say 3 in the beginning of the learning. Means what? There is a error. So then your neurons has to be trained such in a way that you have to get the exact output. Same thing is what we try to build in the form of a artificial neural network, ANN. Now this class objective is how to use ANN for image processing, what is the problem with ANN, and how to bring convolution neural network here. Is it clear now what we are going to discuss? Right? Now whether I am allowed? I put it here better. Yeah, all right. Yeah, okay. See, Indian teaching, board teaching, it goes into the brain. All we are studied this, right? Tell me few words related to biological neuron. Nucleus, soma, arc, center, axon, very good. Dendrites, correct, na? Now, so one neuron gets information from other neuron. There are 10 power 11 neurons in the brain. There are 10 power 11 neurons on the brain, and these 10 power 11 are connected, interconnected. So when they are interconnected, right, so it look like this. So this is what the MNIST data set. The words, our objective is to do hand digit recognition, example, but applications can be anything. Okay, right. So yeah, so this is a biological neuron, right? Whatever the words you said, dendrites, cell body, axon, right? Axon, right? So now what is the function of dendrites? What are all I am speaking, I'll give you this with Python code. In the beginning, concept should be very clear. Okay, what all I am teaching, I'll verify this with Python. That's for guarantee. So when I show you the code, then again come back to concept. No, concept has to be covered and then go for the code. Right. So now let us go ahead. Now this dendrites collects information from the other neurons. Right. When neuron is fired, it is firing through axon. So when neuron is firing, the information is transmitted through axon, and again at the axon there are dendrites. And then the meeting points of this dendrites, there is a term called synapse. So our information lies in synapse. Whenever we see a person, like we know, but we don't recollect like this is the guy. But after some time we recollect, array, he's Suresh or Ramesh or somebody. That means your neuron got fired, your information is somewhere is got retrieved. Right, so the neuron which are getting trained and then the information which we are calling is there in the form of synapse. Right, so a biological neuron, the working will be like this. All the dendrites collects information, the inputs to the neuron, okay, and then the weights which are connected means the axon, right. So the weights which are there are the connected. This point is what the synapse say. So this is the axon from the other neuron. Right, and then this is, this information is getting collected at soma. So the information is collected through dendrites, getting multiplied with weights, which is synapse. So the synapse equivalent in artificial neural network is weights. Dendrites are inputs. Synapse is what? Weights. So information is getting multiplied with weights. In the neuron cell, all the information getting collected is a biological reaction, chemical reaction, which produces a voltage of 0.7 volts. If the chemical reaction results in the voltage more than 0.7 volts, neuron is said to be fired or not. Otherwise, no. Right. So this firing is generally a non-linear action. To bring the non-linearity into the network, we bring activation function. Okay, we bring activation function. So the information are getting multiplied and then getting collected at soma, summation is done. So mathematical model of this is what we call it as perceptron. Right, perceptron, right, and then the ANN, it looks like this, input. So inputs are multiplied with weight synapse and then getting collected at neuron, soma, right, and then the output here is getting added up. So can you tell me what is the mathematical equation at soma? Sigma I is equal to 1 to n xi wi. Yes or no? Right. Now, sometimes the triggering will not happen, right, when we see our friend or something. So to make it happen, there is something responsible. And to make it triggering happen, we add up a term called bias. So a constant will be added to a neutron, right? So then the output of a neuron is summation I is equal to 1 to n xi wi plus b. Plus b. What is b? Bias. A constant which is getting added up. Correct, na? Up to this point is clear? Right. And now the firing of the neuron, see why we go ahead with neural networks is, Now let us take signal processing point of view. We need to design filters or something else. The noise which is available is what? Non-linear, or the action which is of non-linear. Tell me one electronic device which mimics non-linearity. The moment we talk about electronic systems, we go ahead with an assumption is LTI. What do you mean by LTI? Linear time invariant system. So we design systems LTI. So to bring the non-linearity, neural networks are best non-linear approximators. So whenever there is a non-linearity, to approximate non-linearity, what we do? We use neural networks. Yes or no? So neural networks, so the output of a neuron is what getting fired. So this firing of a neuron is what we try to take it up as a through an activation function. So y, if I try to take output of a neuron, now tell me, so y is function of, right, y is function of summation I is equal to 1 to n xi wi plus bi or b naught, right, bi. This function, to make it non-linear functions we consider. So this activation function, tell me few activation functions which are used in neural networks. Tangent, hypertangent, sigmoid. Yes or no? Sigmoid. These days you are hearing this word ReLU, softmax. These are all activation functions, right? So now if you have to understand this very clearly, then only you can write your program, otherwise no. This thing I will try to show you in program. Okay, yeah. So now y, the output of a neuron, right? So now if you try to take this, f is an activation function, and this activation function, if you try to take it as a sigmoid function, can you tell me what is the expression for y? Sigmoid function is this. What is sigmoid function? 1 by 1 plus e power input of the neuron. What is input of the neuron? x1 w1 plus x2 w2 plus x3 w3 is the input of the neuron, correct? So if it is the input, 1 by 1 plus e power minus input. Yes or no? So now if you consider this, so this function y of n, I can write it as 1 by 1 plus e power minus bracket of summation I is equal to 1 to n xi wi plus b naught or bi. All right, yeah, done. Now such networks are connected in n number, and to update the weights we will be using back propagation network, right? To appreciate CNN, you should know what is the problem in ANN. Okay, why we are going for CNN means you have to know what is the problem with ANN. So then you should know what is ANN. Okay. So now you have input layer. So now you have n number of hidden layers. One layer, second layer, okay, third layer and all. Lakshmikant. అది మీది ఇచ్చేసండి, నో ప్రాబ్లం. ఫొటోస్ నాకు డిపార్ట్మెంట్ వర్క్స్లో స్టూడెంట్ రిక్వెస్ట్లో శారద అని ఒకటి ఉంటుంది, దాంట్లో ఫొటోస్ అన్నీ కూడా ఉంటాయి, ఫొటోస్ సిగ్నేచర్ నేను పంపిస్తాను, ఆధార్ పంపిస్తాను. ఓకే, Right. So input layer, hidden layer, second hidden layer, then output layer. Okay. Right. Now, when you give input, you get output. Then, like when you are learning, you compare with the teacher, right? Beta, how many these are? Means with desired thing you are comparing. If there is an error, this error has to update the weights of the network. In CNN, the last layer is dense layer, which is of ANN. Even in CNN, the last layer is what? A dense layer. Dense layer is of this network only. Okay. So for that you have to know this. Right. So now you tell me, when you give input, you get an output. This is called feed forward propagation. And you compare this with your output. Whatever the error you get, you back propagate the error. You know this concept means I live. This itself 2 hours I'll teach in the class. Okay, I'll just give you the brief. I will not go into this. Right. So now, just tell me only the generalized thing. Generalized thing. This is a network like this. From one neuron to multiple neurons we are going. X1 to so on n number of neurons in the input layer. How many neurons are there in the input? N. To address any one particular neuron in the input layer, I call it as ith neuron. I. Right? No processing happens at the input side. Processing happens at the hidden layers. Processing means that sigmoid function wala. Right? So now there is a hidden layer Z1 to ZP. How many number of layers are neurons are there in the hidden layer? P neurons are there. Okay, P neurons are there. To address any neuron in the hidden layer, we call it as jth neuron. Can you tell me what is the input of Z1 in? Z1 in. Chapandi? Tell me. What would be Z1? Z1 is there, no? And weight between first neuron and first neuron in the hidden layer is denoted with V11. So weight between ith neuron and jth neuron can be given as Vij. Correct? The bias is a VO, right? VOP. So P neurons are there. To address it as VOP. So can you tell me what is Z1 in, or can you tell me what is ZJ in? What is ZJ in? Chapandi? Questions are not allowed. Going into mathematics. This is not at all allowed. Dabba you draw, from Dabba you explain. No research will come. Communication system, when you explain, Dabbas only we draw, no? But what is there in the Dabba? So much mathematics things, right? So tell me, what is ZJ in? Z11, tell me Z11 in is what? X1 into V11 plus, if there is one more X2, then V1 X2 into V21 plus so on up to Xi into Vij. Kada? Like this. So now generalized expression you tell me, Zj in. What is Zj? Jth neuron output. Jth neuron output is what? 1 by 1 plus e power minus Zj in. Now what is Zj in? summation, how many neurons are there? I is equal to 1 to n xi vi j plus vo. Simple mathematics lo multiplication addition is there, no? So Z in J is summation I is equal to 1 to n xi vij plus voj, right, plus voj. So this is Z in J, and what is Zj out? 1 by function, which function? Activation function, sigmoid activation function, which is 1 by 1 plus e power minus something. Correct? Right. So this is Z. Now there are m neurons in the output layer. To address any neuron, I am calling it as K. Right, K. So what is yk out? What is yk out? Yk out is 1 by 1 plus e power minus yk in. What is yk in? Sigmoid j is equal to 1 to p. The weights between these two are w. Right. So w j m. Right. W j k. Kth one. Right. So the output of the one is j is 1 to p zj wjk plus wok. Right. So this is what the output. This is called feed forward propagation. Now feedback has to be happen. Right. Feedback has to be happen. Right. This is what the network you consider. How many number of neurons in the input? Here. 2. How many neurons in the hidden layer? 2. How many neurons in the output layer? 2. So it is a 2-2-2 network ANN. So when it is 2 and 2, 2 input neurons are there, 2 hidden neurons are there. How many weights are associated with? 2 input neurons are there and 2 hidden neurons are there. So x1 h1 x1 h2 x2 h1 x2 h2. How many weights are there? 4 weights are there. Right, I bring this concept. Right, so 4 weights are there. Correct? So now these concepts I bring in. So I do feed forward operation, I know. So here the operation is when x1 is 0.05, x2 is 0.10 and b1 is what it is given. b1 is the bias and y1 is what it is given. So w1, w3 are also randomly it is given. So target 1 is 0.01 and target 2 is 0.99 is what it is given. Okay? Right. So now I can do feed forward propagation. All of you can do feed forward propagation. Right. If I want h1 in, what is h1 in? If you know, then only you can understand how many number of computations are required and then how this CNN is reducing the computation. For that point only I am explaining. CNN reduces the number of computations. So how it reduces number of computation? If you can know, if you know the ANN. Okay. Alright. Okay. So now what is H1 in? H1 in is x1 multiplied with w1 plus x2 multiplied with w2. What is h1 out? If its activation function is sigmoid, 1 by 1 plus e power minus h1 in. Yes or no? That is h1 in. What is y1 in? Two only are there now, sigma not needed. H1 out multiplied with W5 plus H2 out multiplied with W6 is what? Y1 in. What is Y1 out? 1 by 1 plus e power minus Y1 in, which we calculated, correct? No? So this you can do. So we can compute, na? Okay, this simple mathematics, multiplication and all we do. So similarly we can do H2 out. Similarly we can do Y1 and then Y1 out Y1. Up to this point is clear. Similarly we can calculate out Y2. Right. So now if you know neural networks, you challenge me. Okay? Right. So now here what happens is error has to be calculated. Right. So here your network is what? So this is what your network. T1 is the target 1, T2 is the target 2. So what is E1? Out Y1 minus T1 is the error 1. Yes or no? Out Y2 minus T2 is what? Error 2. Total error is what? E1 plus E2. But both errors we are getting, so both errors should be given equal weightage. So error can be positive or negative. To consider error, we square it. So E1 square plus E2 square. To give equal weightage, half E1 square plus half E2 square, which is equal. Right. So this is what we do here. This is understood. How to calculate error is understood. Up to this point is clear. See, if you attend a session, you should understand and you have to implement this in Python. I'll show you. I'll execute this and I'll show you in Python. Okay? Alright. Yeah, done. So now you know how to calculate error. Error 1 and error 2 and total error. Now weights need to be updated. Right, weights need to be updated. Then this generally we use backpropagation algorithm for updation of weights in neural networks. So what is that? We will try to see now. Now, see what is this backpropagation algorithm? I will tell you with the help of an example. You know die. So if I throw die, what is the outcome? Any value between 1 to 6, correct? Now, how this backpropagation algorithm works? This backpropagation algorithm is proposed in way back, which is based on gradient descent method. This gradient descent method is in 1971. It is proposed in US. Right? It's a very simple optimization algorithm. First order optimization algorithm. How it works? I will give you with the help of simple example. Assume that I have 100 phase die. So how many outcomes I may get? Any value between 1 to 100, right? So now my sample space is 1 to 100. I have thrown die, right? So I got a value 40. I asked my friend, guess how much it is. Funny games, how so many times we do, na? So he can guess any value between 1 to 100. Let us say he guessed a value 80. Then I said wrong. What is true? 40. What is the estimated? 80. True minus estimated is what the error. Error is the information I am giving, right? In the presence of teacher it is done. That's why it is called supervised learning. Right? Okay. So now I am updating the weights. Right? So now array, I will give you chocolate, you guess ra. So he can go to a value 80 to 100 or he can go to value 80 to 1. Anything possibility is there. Guidance should be given. So let us take your friend is guiding. So you guessed a value 70. Right. Then I said, bah, you are in the direction. So when he is guessing the next value, will he go to 80 or will he come down? Come down. Information is there, no? So this information of you are correct and right direction is what I gave the information. Correct, no? So when he is updating himself as an information, correct? So I will tell, array 10 rupees chocolate, I will give you a guess. So he is guessing now 70 to 60. So what is the step length? Earlier he guessed 80, now he guessed 70, now he guessed 60. What is the step length? 10, 10, 10. So then, closer, very closer you are. You are about to win the chocolate. Then he is guessed 50. I am taking it from pocket. Then he said 40. Achieved or not? This is what written in the form of an algorithm. That is what called gradient descent algorithm. When you update the weights of neural network, W of k plus 1 is equal to W of k plus the step length is there, no? Learning rate parameter is what we call. So this is called eta. And you are coming in a right direction, right? See, if error function is of this form, to find out the minimum value of this particular function, what we do? We differentiate. Yes or no? We differentiate. So when we try to differentiate from this point to this point, slope of this and slope of this we try to take. So slope is negative. Slope is negative means we are going in right direction. Friend is telling you are correct direction. So dou by dou w, okay, means differentiation, means we try to take del is gradient is what we consider. That is what called gradient descent function. So now here in the neural network, to update the weights of W5 using gradient descent now, W5 new, tell me, W5 new is W5 old minus learning rate parameter into dou W5 by dou E total. It means this error, na, dou E by dou W means what is the contribution of this W in the error, right? We calculated E total. So dou E total by dou W5 is what we consider. Hold concentration, hold. When you know the concept, then only you try of writing code. Okay, right. So then now here now W5 new, if I update the weights, what is the contribution of W5 in total error? So W5 new is W5 old minus learning rate parameter into dou E total by dou W5. Contribution, slope is what I have to calculate, na? Okay, right. So now here if you try to see, yeah. So when I try to calculate dou E total by dou W5, what is E total? Of T1 minus out Y1. మీరు మాట్లాడితేనే కొంచెం this lecture will go up. What is E total? T1 minus out Y1 plus T2 minus out Y2. Right. So dou E total by dou W5. So is there any W5 term there to differentiate? No. Then we use chaining rule. But what is out Y1? 1 by 1 plus E power minus Y1 in. Is there any W5 there? No. Then what is Y1 in? W5 into H1 out plus W6 into H2 out plus bias. So now W5 is there here. So then I can write a chaining rule, na? It's raining. Okay, so now you tell me dou E total by dou W5. If I want to write, then I write a chaining rule, na? So what is the chaining rule? Dou by dou E total by dou out Y1, dou out Y1 by dou Y1 into dou Y1 in by dou W5. ఇంత జరుగుతుందండి ఆల్గరిథంలో. This much happens in the algorithm. Okay, now you tell me how many multiplications are there, how many additions are there, how much derivations are there, yes or no? Right, so this is only one weight. Such how many weights need to be updated? 4 here, 8 weights need to be updated, correct kada? 8 weights need to be updated, right? So one weight only. Now I will stop here. Neural networks, you got an thing, right? How the weights and all it is getting updated. So coming to the digit recognition, what is my data set? MNIST data set is what I said. MNIST is the data set. MNIST, MNIST data set is there. So in this, so what is the size of the image? 28 by 28. So 28 by total how many pixels? 28 cross 28. 28 cross 28, total how many pixels? 28 into 28, 784 pixels. To process one pixel, I need one neuron. So how many neurons I require in the input side? 784 neurons. Understood? Right? Understood? There can be any number of hidden layers. In 1970s, 80s, 90s, 2000 and all, this maximum neurons are used, hidden layers are used are 1 or 2. But this deep learning which comes in picture having hundreds of hidden layers. 100, 200 hidden layers. That's why it is called deep. Right, why it is becoming popular? Earlier computations are very difficult, but now you can do your computation in cloud. You can use your Google Cloud and then you can process your image. No need of any computation here in the college. So cloud you can use, right? So cloud computation you can do, right? So hidden layers are 15. So inputs are 784. Hidden neurons are 15. How many weights are associated with? When it is 2 and 2, how many weights are? 2 into 2. When it is 784 and 15 hidden neurons, so this how many weights associated with this? 784 into 15. Those many weights need to be updated. One weight itself, chain rule, 3 differentiations. And summations and multiplications. Now you see the computational complexity. Right. There are 15 layers here. This is a digit recognition problem. How many number of neurons I require in the output? How many digits are there? 10 digits. So how many neurons I can expect in the output? 15, 10 here. So how many weights are there between hidden layer and then output? Multiplication only. 15 into 10. అన్ని వెయిట్స్ అప్డేట్ చేయాలండి. Is this clear? Neural networks is clear. Shall I execute this in code and then show you? Ready? Or lunch? Right. So if I have internet, I think I can connect it to internet. Night, I think it was 1 o'clock when I executed this. But internet cable, I think port is not. But I can show you. I can maximum. If I face problem, then definitely I take assistance. I don't want my computer to get burdened. So whose computations I am using in? Google Colab, means cloud. Right. So TensorFlow is what you have to import for this. TensorFlow is a library where you have this inbuilt functions. Okay. So then from for plotting you can use matplotlib. For doing computations, multiplications and derivations and all, you import library NumPy. 3 libraries I am importing. So I try to do the computation. Why sir, if you can give me this. Internet is required because 6 minutes it takes to train the 100 epochs I have taken. So somebody, if you can call, I think my system, I through my mobile I connected it to yeah. So Keras is what the thing I use to access my data set. Which data set I am using? MNIST, MNIST. So that you can get it from Kaggle website. Okay, and then so these are the digits. Are there written digits? Are there 70,000 images are there? Okay, around 70,000 images are there. So the images are like digit 5, 0, 4, 1. 1 is written like this, 4 is written like this. This data set is there. Okay, and among this 70, I am using few for training, few for testing. I need the samples for training and testing. Na? So few I am using for training, few I am using for testing. So 60,000 I am using training images, testing images I am using 10,000. What is the size of the image? 28 cross 28. Okay. Right. Now when I try to take an image, the pixel intensity values can vary from any value 0 to 255. So then if I do normalization, then perfectly it works to the neural network. So I am normalizing it, I am dividing this by 255. So all the values are normalized between 0 to 1. Right. So now then if I, yeah, if it is the image data set, which color is dominant? If 7 is there, 2 is there, if it is 28 cross 28 pixel, which color, there are 2 colors only, black and white, na? Which color is the dominant? 7, if you try to take 7, black. So if I plot histogram plot, which pixel should be more in the data set? Black. Means 0, na? Yeah, 0. So I want to see the histogram of this. So image processing, I think when you have done, so it plots histogram. So which pixels are more? Black pixels are more, right? As the digit is 7, black and white image only, correct? Yeah. So then Yeah, the neural network which I am using, I no need to write coding of each one. It is already available in the library called Keras, right? So what is the input layer? How many neurons should be there? 28 cross 28. Hidden layer, I am trying to take 512 hidden layer, and then 512 hidden layer, and dense layer means in the output layer 10 neurons I am taking. So what is my structure? Input layer 784, hidden layer 512, another hidden layer 512, output is 10. This is what my structure. So Keras take care of this, right? So I import that and I define my network here. It is a digit recognition problem, sir. When it is a digit, how many digits would be? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 10. 10 digits. So how many neurons I require to represent these digits? 10. So in the first neuron, if I get 0, means the digit is not 0. If I get 1 in the first neuron, means what is the given digit? 0. Output of the neuron can be either 0 or 1 only, na? Yes. So this is how. So first neuron, if it is, then 0. Second neuron, if it is, then 1. Second neuron, if it is, then 2, 3, like that 10 neurons. Okay, so this is a simple digit recognition problem, right? So here it requires 6 minutes to training the network. Okay, so each one takes around 16 seconds, right? So total 100 are taken, 100 iteration. Then only I am getting what is the accuracy I got. Training accuracy 99%, and this model I am saving, right? Then when I am activation function ReLU, sir. ReLU. And equalizer in the output, it is softmax. In the output, to make it 0 to 1, we are using softmax. Simple concept called neural network and its implementation for the digit recognition. Is this understood? No? If somebody helps me out, for training this, I can show you the output. Now let us go to the topic. Convolution neural network is what we have to discuss, right? Okay. So these neural networks, we can use it for classification. As I said, binary means tumor classification and so on. So we can use this X-ray as an input image, and then output we can say whether the fever is normal, bacterial or COVID or viral pneumonia fever. So for classification we can use CNN. This is one application. So the moment I take about an image, yeah, this is what my image is. This image is of grayscale image or color image? Color image. What is the size of the image? 1920 cross 1080 cross 3. So if I want to process this image, how many neurons I require in the input? How many neurons I require in the input? Just now we have seen 28 cross 28. This is a HD image. So this is a HD image. Within this HD image 1920 cross 1080. So how many neurons we require in the input? 1920 cross 1080 cross 3. Correct? Right. So now, first layer will be 6 million neurons I require. How many neurons I require? 6 million. Right. If I use hidden layer 4 million neurons, how many weights I need to update? This is what the problem. 24 million weights I need to update. This is not the case in the year of 2000-2010, before this cloud concept came, your computations are done in the cloud, right? Okay. See, objective, we should not deviate from objective. How to use convolution neural network for? Now, what is the problem with ANN is what we are discussing. So, updation of 24 million weights is very, 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 very difficult. It's a time taking process. So, in CNN, we reduce the number of computations. How? Let us try to see. Ready? Yeah? Yes, sir. Huh? Yeah. So, we will see how this can be done. So, there are 24 million computations, multiplications and then additions, and then that's what is done. So, too much of computations is what is in ANN. Okay, and sensitive to the location of an object. That means what? When I try to do the digit recognition, actually, when I try to do the digit recognition, right? So, if I train my neural network a digit 9 like this, a trained network is there, but somebody can write a digit if it is shifted to the left, but the neuron is trained with the middle half of the thing, then it will not recognize it as 9. Okay, right? Or somebody, if somebody writes a 9 like this, if it is trained with this weights, it will not recognize it as 9. So, it is, neural networks are sensitive to pixel intensity thing. So, this is what the problem it is written here. Sensitive to location of an object. If object is changing its position, if it is not trained to that, so that's why it will fail in that particular cases. Right. So, up to this 1 hour class discussion, I hope you can understand this now. ANN for object classification means digit recognition classification. So, Y784 hidden and then how many number of weights and all, you are very clear now. Right. So, now let us go ahead with CNN. So, now we do CNN. Right. What is the time I am allowed with, sir? 12:30. What is the time now?
12:30. 1 minute late. We have today is Friday also.
According to that, I can design my lecture. 10 minutes is the time. So, objective straight away put like we need to reduce the computation. So, have you seen this CNN structure any time? In CNN, what you get? You have these things: input, convolution layer, pooling layer, convolution layer, pooling layer, convolution layer, pooling layer. Like that, 100 hidden layers are there. That's why it is called deep neural network. Now, how to reduce the number of computation? This is what has to be seen, right? So, we try to perform convolutions. Right, we try to perform convolutions. You know convolution? Little bit? Right, so now I will give you the so see, one thing I will tell you in 10 minutes, how the computations are reduced compared to ANN and CNN. Okay, right, so now if you try to see this, so this is my, let us take, this is my input image. What is the size of input image? 6 by 6. What is the filter size? 3 by 3. 3 by 3. If I convolve, what is this filter? Why this all of a sudden filter came into picture? See, this is the object. When you are trying to see this object, what is this object which is there in the image means what we see? Is it a dog? No. How do you say it is not a dog? Our neurons got trained. Dog has some kind of ears. So ear is a feature. Eyes are feature. Nose are feature. These features are filters.
Each part.
Okay. So, yeah, if eyes is there, nose is there, ears are there, head is there. So, head is there or not? Complete head is there or not? One more filter. Now, similarly, hand, leg. Both are there, body. One more filter we use. So this is filter. Filter concept is clear. How our brain thinks the same similar way we use. Okay, right. So now our objective is to reduce the number of computations. Now, so let us see the conversion. So now filter is the feature. So we try to extract features from convolution layer. Two things straight away put in mind. Number of computations has to be reduced, and if object is there anywhere in the image also, we have to identify it is that.
With the help of filter we are using.
Convolution, if you use, this training concept and all go off.
Okay.
How that is, now let us try to see. Now you are performing convolution. So when you are performing convolution, 3 into 1, 0 into 0 plus 1 into, this is how you do, no? Right? Then you shift by position 1 or position 2. So if input image is 6 cross 3, 6, then in filter is 3 cross 3, what is the convolved image? If n cross n, if it is f cross f is what? Filter size. If f cross f is the filter size, n cross n is the input image size, n minus f plus 1 is the result. So what is n here? What is f here? 6 minus 3? 3 plus 1? 4 cross 4. See, that is what you can check it out. When you try to do convolution, then you get this. One more convolution, you get this. One more convolution, you get this. One more convolution, you get this, right? So like this, you try to do convolution. So this is what the convolved image. So this convolution neural network, the first stage of the convolution, first stage of the layer is convolution layer. In convolution layer, we extract features. In neural network, we extract features and give input to the neuron. But here there is no, your convolution layer itself will extract the features. Done? Up to this point understood? Right. So this is what convolution. Now, the moment, when do we go for neural network? When there is a non-linearity. So we have to introduce non-linearity. This non-linearity can be introduced using activation function. ReLU could be the activation function which can be taken. So convolution plus ReLU. So this is n minus f plus 1. This is understood. So now let us try to take, if it is a digit recognition problem. Right, if it is a... This is also, the question is like this. We require training, means fixing of hyperparameters. Training is not the conventional training which we do in the neural network.
ReLU is my hyperparameter.
ReLU is?
What is my hyperparameter?
Here hyperparameters are like, how many number of, now if I am doing convolution, who will give you the size of the filter? How many number of filters you require? So now I am doing X-ray image analysis. How many filters I do consider is, which is a variable, is hyperparameter.
You are moving back, look, podium.
Yeah, okay. All right? Okay.
Yes, sir.
Right. I can continue now. So if it is a digit recognition problem, listen carefully. If it is a digit recognition problem, what are the features? In digit, there is a loopy pattern in the top, vertical pattern in the middle, diagonal pattern in the, if these things are there, then that is 9. So let us take one filter I required for loopy pattern, one filter I required for vertical line, one more filter I required for diagonal line. So if I am performing convolution here, so wherever the object is, then I can definitely, so now let us take, this is loopy pattern filter, this is vertical line filter, this is a diagonal line filter. So if I try to do the convolution here, okay, if I try to do convolution here, so if it is a loopy pattern, if loopy pattern is present in the image, then I will be getting my 1 in the sense there is a loopy pattern in the top. right? Similarly, I do convolution, right? So here if it can be 6 loopy pattern in the bottom, down. Okay, so 8 2 loopy patterns, right? So this is what I try to do, 9 and 6 and so on. So filters are nothing but filters are nothing but the feature detectors. Okay, they are feature detectors. So now 3 filters are there: loopy pattern filter, vertical line filter, diagonal line filter. So if these 3 are there, these features is what we try to extract. So this is what convolution, right? Then the next one is to introduce the non-linearity, we use ReLU. Right, we use ReLU, convolution plus ReLU. But our objective, what we started, is not achieved yet. Computations are not reduced yet. So computations are reduced in the next layer, which is called max pooling layer. Okay, max pooling layer. How that is, now we will try to see. So this is a simple example of your ResNet or VGG16 kind of thing, where you have this kind of structures, convolution. They are fixed. After so much training, networks are fixed. So this is what one particular image. After attending my lecture, this is from one paper snapshot, where you do your X-ray image analysis. What is the first one? Convolution. What is the input image size? 227 cross 227 cross 3. How many filters are used? How many filters are used? How it became 55 cross 55 cross 96? Then that became. Computations, how it got reduced is what we have to understand. Okay. So one more layer, max pooling layer, is what we have to understand. Okay. So now let me finish this and come back to this. Okay. So here the filter size used is 11 cross 11. Striding used is 4. Okay, striding used is 4, and then I will come to the computation. So now here, as I said, it is insensitive to location of the object. Eyes, wherever they are, it will identify convolution. So that is done. Okay, time is not there, I am skipping. Right, so this is one filter, this is one filter. Yeah, head is there, so like that it will do. Right, so the next one is what? Yeah, ReLU. ReLU is no need to explain at this particular junction. Yeah. Okay. So this is, if it is less than 0, 0, more than 0, whatever input is the output. So convolution plus ReLU, to introduce the non-linearity, we are putting this ReLU function. Okay. So ReLU helps in making the model non-linear. Okay. So but pooling layer is used to reduce the size. So how that is, now let us see. So this is the input image. When you try to see when you try to operate the filter, if I operate it by 1, we call it as striding 1. If I operate this by shifting by 2, then it is called striding. So take this image. Okay, take this image. Am I allowed to speak? Yes, sir. Sure. Only 2 concepts need to be verified: computational complexity and insensitive to 5 minutes. Okay, all right. So I thought of showing verification of this also. Yeah, so this is my, let us take, this is my input image. So my filter size is 2. Maximum pixel intensity value in this is 8. 5182 in that. And if I move the filter, the next filter like this, then it is called striding by 1. And if I move the filter 2 steps, then it is called, see here in the beginning it is then it is moved two side. It is called striding by 2. So when I try to perform convolution, n minus f plus 1, n minus f by s plus 1, where s is a striding. Okay. So I do max pooling. So maximum of this is 8, maximum of the next is 9. So maximum of this is 3, maximum of
9 you're getting from the first to the third column.
yeah, striding is 2 here, sir. First filter is 5182. Striding done two shifts. So when it is 2 shifts, 3492 is the 3492. The maximum is 9. Striding is based on the position of the striding. Shifting by 1 means you get different size. It is shifting by 2. So n minus f by s plus 1. So there is one more concept called padding. So what is padding? When I try to do striding, edge pixels are covered only once, but in between pixels are covered more than once. So more information is preserved in the between. So then what I do, I add zeros. Right. So I add zeros. Right. So I add zeros here. And when I add zeros, when I try to do stride, edge pixels also covered more than once. That concept is called striding. Padding. So how many concepts, how many words here? Convolution, striding, padding, pulling. Right. So now the formula is this: n plus 2p minus f by s plus 1. Done? Right? So now I try to take this example. What is the input image size? 227 cross 227 cross 3. Those many neurons I required in the input. I need to reduce the size. So now how many filters are used? 96 filters are used. How many, what is the size of the striding? 4. What is the size of filter? 11. Absolute silence. ఇప్పుడు చెప్పండి, input image is this, right? My input size is 39 cross 39 cross 3, filter size is 3, striding is 1, padding no padding, 10 filters are used. What is my output size of my image? So n is 39. What is f? 3? 39 cross 39. F is 3 cross 3. Right. Striding is 1. No padding. So n plus 2p minus f by s plus 1. So what is the output size here? Tell me. What is the output of convolution? N is how much? 39. So n is 39. What is f? 3 cross 3. Padding 0. So 39 plus 0 minus 3 by 1 plus 1. 36. 36 plus 1. 37. Is it all right? So 37 is what I get. 37 cross 37. Cross how many filters? 10 filters are there. Right, roughly tell me 39 cross 3. What is the size? Tell me 39 cross 4096. Quickly, see, convolution computations has to be reduced. Let us try to see here whether it is reduced or not. So 39 cross 39 cross 3. 4563 neurons is what I required. Okay, so now I am doing convolution. So 37 cross 10 is what I got. Then next stage of convolution is used. So filter size is 5. Striding is 2, padding is 0, 20 filters are used. So what is N? 37. And what is striding? 2. So 37 plus 0 minus 5. 32 divided by 2. 16. 16 plus 1. 17. So if I do convolution after that, what is the size of the output size of the image? 17 cross 20 filters are there, so 20 comes into picture. I didn't discuss that concept here because of the time thing. So 17 cross. What is the next layer? Again, after that,
But still, are we just reducing the first form or we are
number of computations, sir. Last is neural network. If I use neural network, 4096 is what I require. Hidden is different. Those many weights I need to update. So let me finish this. So filter size is 5. So padding is 0. Right. Striding is 2. 17 minus 5. 12 by 2. 6. So 6 plus 1. 7. So what is the size, output size of that third layer? 7 cross 40. So what is 7 cross 40? 7 cross 40. 1960. Neurons I reduced from 4096 to 1900. Right. So that is what convolution neural network does. Now you can understand this, no? Tell me, if I use neural network, how many neurons I required actually to process an X-ray image, which is of 227 cross 227 cross 3. Tell me what is the number of neurons I require. 227 cross 227 cross 3. But in the size given, it is of 96. So you 55 cross 96. How you got? You understand? What is N here? 227. What is the filter size here? 11. What is the striding? 4. N plus 2p minus f by s plus 1. Then you get 55 cross 96. So like that, convolution pooling. So then 4096. You are reducing the neuron size from 227 cross 3. Total how much? Done sir. 227 cross 3. 1,54,587 neurons requirement to how many I reduced? 4096. So research paper, here it is. They're like, then softmax. This is what convolution neural network. Right. And then the insight. I think after completion of my lecture, I think you can understand now this complete CNN. Convolution plus ReLU pooling, convolution plus ReLU pooling. Last note, if your principal permits, so this is AICTE. Done sir. If they want me to stop it. So this is AICTE. You can understand now. AICTE. Ramayanam, Rama Sita. After listening Ramayana, who is Rama, who is Sita means, you can understand, no? Then this is AICTE. This is VGG 16. One more standard architecture. Each one is a chapter. These days people are working in TinyML. This deep neural network should run on Arduino board.
Yes.
Okay. All right. So this is VGC 16. So VGC 16, this is standard fixed. Phase detection YOLO. Okay. So this is fixed. This is VGG 16. This is ResNet, net, so on. Whatever they propose, you have to teach. That will become academics. Today, CSC branches are becoming 4. AIML, data science, this thing, that thing.
Machine learning, deep learning.
So, whatever the terminology, this is the industry-driven society. Whatever industry speaks, you should speak. Otherwise, you need to update. Otherwise, you will be out of date. So, these FDPs should give you a scope of updating yourself. So, thank you very much for listening to me. If you have any questions, you can ask me.